if you guys can hear me. Just looking at these elements in the periodic table, we need to know how to recognize the proton number, neutron number, electron number, and the mass number of all these elements. I'll just randomly pick one element. Let's say I have potassium here. How many protons? How many protons? Proton is the smaller number. We have 19 and 39. So the smaller number is 19. So 19 is the proton number. The number of electrons. The number of electrons. It will always be the same as the number of protons. They cancel each other out. Not for ions, which we'll discuss later. For now, every atom will have the same number of protons and electrons, 19. The number of neutrons would be 39, the bigger number minus the smaller number, which is 20. Shahnawaz, is this making sense? This is how you recognize the number of protons, electrons, neutrons. Okay, what is the nucleon number of potassium? Nucleon number. Nucleon number. Nucleon number is the mass number. Nucleons is protons plus neutrons. The number of nucleons, 39. Right? So 39. The number of nucleons. Nucleon is the mass number. Okay. Let us move on. Now defining mass number. Mass number is your number of protons plus your number of neutrons. Why do we call it the mass number, guys? The reason being, protons and neutrons, they have a mass of relative atomic mass of 1, but electrons, they don't have any mass. Negligible mass, right? 1 over 1840. So we call it the nucleon number. Nucleon means everything that is in the nucleus of an atom. In the nucleus, you have protons and neutrons. Mass number, every particle, every subatomic particle which has mass, which would be protons and neutrons. Because electrons have close to no mass. So sum of protons and neutrons would be your nucleon number, or you can also call it the mass number. So in the periodic table, the bigger number is the mass number or the nucleon number. The smaller number is the proton number. For this chlorine, this is chlorine, symbol is Cl. How many protons do we have? Protons, 17. The number of electrons for an atom of chlorine, 17. The number of neutrons, 35 minus 17, which would be 18. And nucleons, or the mass number, of course, would be 35, the bigger number. Okay, Inza had a question. Sir, if nucleon number is protons plus neutrons, then how come in potassium it was 39? Okay, shouldn't it have been 39 plus 19? Let me go back. Okay, now this is the periodic table. So as you said it yourself, nucleon number is protons plus neutrons. We have 20 neutrons, right? 20 neutrons, and we have 19 protons. When you add them, 19 plus 20, what do you get? 39, right? Is this clear now? Okay. Let me go to that slide one more time. Okay. Now, for carbon, what is the mass number? For carbon, mass number. Mass number. Mass number is protons plus neutrons, everything that has mass. 12. What is the nucleon number? Nucleon. That is also 12. Mass number and nucleon number is the same thing. The number of protons. The mass number is the bigger number, this 12. The bigger number is the mass number. And the nucleon number is also the bigger number. Protons, number of protons would be the smaller number, which is 6. The number of electrons, same as the number of protons, 6. The number of neutrons, coincidentally 6, coincidentally. So basically 12 minus 6, the mass number minus the proton number, which is coincidentally 6 as well. Yes, that is correct. In the mass number and nucleon number is the same thing. Is this clear now? Any doubts? Any doubts? Okay, now these are the formulas. These are very straightforward. So mass number is basically number of protons plus neutrons. So if you want to find the number of neutrons, you just take protons to the left hand side. It would be mass number minus proton number. The number of protons is basically the smaller number, right, in the periodic table. So for carbon, this is the number of protons. For chlorine, the smaller number is 17. So this is the number of protons. For a neutral atom, the number of protons and electrons would be the same. Ions are different. We'll do that later. But for now, we are just doing neutral atoms. Atoms would have the same number of protons and electrons. If you want to find the number of neutrons, you can see mass number, the bigger number, minus the smaller number. And atomic number is just your proton number. Every element has a unique proton number. Proton number is unique for every element. Let's go to the periodic table to prove this. Unique means different. The smaller number is the proton number, right? Yes, all atoms are neutral. Now, you can see the smaller numbers are written at the top in the periodic table, right? So hydrogen has 1, helium has 2, lithium has 3 protons, beryllium 4, then we have boron 5, 6, 7, 8, 9. Every next element has one proton number greater than the previous one. So the arrangement in the periodic table is because of the number of protons. Every next element has one proton number greater than the previous one. You would see, you can check this periodic table, no two elements have the same number of protons. Proton number is unique for every element. Of course I will, Inza, don't worry, I will. Is this clear? Every element has a unique number of protons. So for example, bromine 35, krypton 36. In the next row, we'll have rubidium, which will have one more, basically 37. Then we have 38, 39, and so on. So proton number is unique. Atomic number or number of protons is unique for every element. Okay. A worked example here, then I'll explain the questions. Determine the number of protons, electrons, neutrons of an atom with the atomic number 29. Atomic number is the number of protons and the mass number of 63. Protons is equal to 29. Electrons are same as the number of protons. So if protons are 29, electrons are 29 as well. The number of neutrons would be the mass number minus, mass number is 63, minus the proton number, which is 29. This gives us 34. Neutrons are 34. That's the answer. Any doubts? Any doubts?